Okay, so I'm going to be taking you through the Summer 2020 Paper 1 for GCSE Maths. It's the higher tier and it's non-calculator, so we won't be using a calculator during this paper. Okay, first question is about the nth term of a sequence. If you remember what you do, you check to see how much it's going up by each time, and it's going up by 3 each time. That means as it's going up by 3, it's going to begin with a 3n. We think what the previous term would be. If you go backwards 3 spaces here, it's minus 2, so our answer is 3n minus 2. Okay, question 2 wants us to show that this fact is true, so they've kind of already given us the answer. Now we can't do these when they are written in this form, so I'm actually going to change them from mixed numbers to improper fractions. 2 and 1/3, you do the 2 times the 3 and then add on the 1. 2 times 3 plus 1 is 7, so that's 7/3. For the next one, we'll do the 3 times the 4 plus 3, that's 15. So it's going to be multiplying it by 15 quarters. Now, before doing this multiplication, you might want to check if there are any common factors in anything in the numerator or denominator that can cancel. Well, the 15 and the 3, these have actually got a common factor. So I'm going to divide the top and bottom by 3. I'll divide that by 3, and I'll divide that by 3. So this then leaves me with 7 times 5, which is 35, and 1 times 4, which is 4. Now 35 over 4, we can actually just go straight to the answer for that. We know that that is the same as 8 3/4 because 4 goes into 35 8 times and there are 3 left over. If you didn't do the simplifying, you'd have to simplify this fraction, but we did the simplifying here straight away. Okay, question 3, it says the diagram shows 4 graphs. We've got A, B, C and D, and we want to complete this table that's at the bottom here. So I think probably the one that you're most likely to recognize is this one, which I think is the quadratic graph that we've got. So I'm immediately going to say that y equals x squared is graph D. Then I think you're probably likely to recognize this one next because these two certainly look similar, and that makes me think that these two are the cube ones. So this is the reciprocal graph, graph A, so I'm going to put letter A down here. Then we just need to decide which of these is with minus x cubed and which one is with positive x cubed. Well, positive x cubed is one that's got almost like that kind of positive correlation, and this one is minus x cubed. So it is B here, and then for this one it is C. So it goes B, C, D, A. Okay, the diagram shows 4 triangles. 2 of these triangles are congruent. Write down the letters of these 2 triangles. Well, we've got some different rules for congruency here. We basically need to have the same angles and the same sides. Well, if you think about what the missing angles are going to be, the missing angle for all of them would be 80 for that part. So that one's going to have it's an 80, a 55 and a 45. So I think this one over here is also going to be a 55. Now we can clearly see that these 2 triangles that we've got here and here must be the same as each other because the 10 centimeters is opposite the 80 and the 10 centimeters is opposite the 80. Here, the 10 centimeters is opposite 45, which won't work, and the 10 centimeters is opposite 55. So the only triangle that will be identical are these 2 in yellow, which is therefore triangle A and triangle D. In question 5, Sean pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for 50p each. Work out his percentage profit. So the percentage profit is the profit that he makes divided by how much that he spent. So it's the profit divided by the spending multiplied by 100. So we should work out how much he actually sells them for to begin with. If he's doing 24 chocolate bars at 50p each, you can think of it like this. I think you probably don't even need to do a long method. 2 50p's is £1, so this is going to be £12. So he paid £10. He sold them for £12, which means his profit is therefore £2. So using this formula, we're going to say that the profit is £2, the spending was £10, and we're then going to times that by 100. So we could just do the 2 times 100, that's 200 divided by 10. That is therefore 20% profit that he's got here for this one. Question 6. ADC is a triangle, and it says that AED and ABC are straight lines. We can see that. EB is parallel to DC. Angle EBC is 148, and angle angle ADC is 63 degrees. Work out the size of angle EAB. EAB means we're going EAB. We want the angle that is at the top there. So we're looking for this angle that we have. and we must give a reason for each stage of the working. Well, I think we could find out what this angle here is because of the fact that this section that we have are two parallel lines. These two angles are co-interior. So you can either annotate the diagram, or we could say that angle BCD is equal to 180 minus 148, which is 32 degrees. And the reason this is true is because co-interior angles add to 180. So I can label that on my diagram. Now when I look at the diagram, I've got this whole shape here. I have a triangle. I know that this angle, and this angle must add up to 180 because it's angles in a triangle. So I'm now going to say that angle EAB, the one that we're looking for, is going to be 180, take away 32, take away 63, which we will very quickly work out. Well, 180 take away 32 is 148. We've basically just worked that out with this information here. So I'm going to do 148 take away 63. 8 take away 3 is 5, and 14 take away 6 is 8. So I'm going to get my answer is 85 degrees. And the reason for this is because angles in a triangle add to 180. And of course, there are other ways you could do this one. This is just the way that I see this one actually working. Okay, so we're moving on to question 7 now. Question 7, it says the table shows information about the heights of some year 9 girls. We've got the least height, the median, and the greatest height. We've got a stem and leaf diagram for some of the boys as well. Compare the distribution of the heights of the girls with the distribution of the heights with the boys. Well, when you have these compare questions, they want us to compare two things. They want us to compare the range for one of the things, and then the other thing they're going to want us to compare is an average. And I think in this case, because they've told us the median, they're going to want us to compare the median. So let's just quickly work out what the range is of the girls. The range is going to be the biggest, take away the smallest. So the range is 170 take away 150, which is 20 centimeters. Now let's find out the range of the boys. The biggest one that we have is the 182, and the smallest that we have is 158. So I'm going to do 182 take away 158. So 12 take away 8 is 4, 7 take away 5 is 2. So the range here is 24 centimeters. So for the range, we can say the boys' heights have a greater range than the girls. Okay, we've already been told what the girls' medians is. Let's just quickly tidy that up. The boys' heights, that should be a little apostrophe. Now we're going to think about what the median of the boys are. Now remember, you cross off from either end, so I'll cross off a few at a time. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then I'm going to cross one off here and one off here. So it looks like the median of the boys is going to be 168, whereas the median of the girls is 165. So I can say that the boys' median is higher than the girls' median. So the median of the boys' heights, the median of the boys' heights is higher than the girls. And this means that they are taller. The boys are taller than the girls, are taller on average. So when you have these things, we do need to have it's something to do with height. It needs to be something to do with taller. It needs to be something that's mentioning about the centimeters as well. It has to be in the context of about referring to height, which is what I've put in this case here, that the boys are taller on average. If we just said that the range is bigger and the median is bigger, that doesn't get you the third mark in this particular question. Okay, question 8. It says a prism is placed on a horizontal floor. They've given us this formula over here which can be useful. It says the prism has a height of 3 and the volume is 18. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force exerted by the prism on the floor. So we are going to have a think about this kind of pair of information that we've got and see if that helps us. Now we should know that the volume of a prism is equal to the area of the cross section multiplied by the length. Now we know that the volume of the prism is 18. We don't know what the area is, but we do know that the length of it is 3. So that can tell me if I divide both sides of this equation by 3, I will get the area is equal to 6. So I now know that the area of the bottom part of this prism is 6 meters squared. And we want to find out the force that's exerted, and they've given us this thing over here. Now, I usually think of this as a triangle with the force that's on the top, and we have the pressure and the area. If we're trying to find out what the force exerted is, we can use this triangle and see that the force exerted are these two being multiplied. So the force that is exerted is going to be the pressure multiplied by the area. They've told us that the pressure is 75 and the area is 6, so we just need to do 75 times 6. Now, I personally would do 75 times 2, and then I would times it by 3. 75 times 2 is 150, and 150 times 3 is 450, because multiplying by 2 times 3 is the same as multiplying by 6. So my answer for this is 450 newtons, and I can just put that in the answer line right here. Okay, we're going to write these numbers in orders of size, starting with the smallest number. The easiest way to do this is if they are in standard form. So this one's in standard form. This one is actually not quite in standard form, so we need to adjust this one. I want it to start off with a 6.72. So if I divide that bit by 10, I'm going to have to multiply this part by 10, which means I'm going to increase the power by -1. That bit divided by 10, this bit I'm going to increase the power by 1 because I'm multiplying it by 10. This one is also not in standard form, so I'm going to divide this by 100, which means I need to multiply this one by 100. And then this one needs to come into standard form. It's going to be 6.72. There are 4 zeros at the beginning, so it's times 10 to the power of -4. Now you'll notice that the start number in all of these is exactly the same, so instead what we're going to do is compare the powers. And we're going to see which of these powers is the lowest, because we're talking about the smallest number. So the one that's got the lowest power was this one that we have at the end here. So I'm going to write down 0.0000672. Then our next smallest one is this one here. So that's 67.2 times 10 to the -4. Then our next smallest power is this one, which is the power of 5. So that's 6.72 times 10 to the power of 5. And then we have our 672 times 10 to the power of 4. Now, if you wrote down the other versions of them that I've done in blue, you'd still get the answer as well. But I like to write the ones that were originally printed for us right here. Okay, so it says given that A over B is 2 over 5 and B over C is 3 over 4. Well, if A over B is equal to 2 over 5, this tells me that the ratio of A to B, because we're trying to do ratio over here, is 2 to 5. And if B over C is 3 over 4, then B to C is in the ratio 3 to 4. So the ratio of B to C is 3 to 4. Now you'll notice that these numbers don't match, but we can multiply both of these ratios so that they do match. We want these numbers here to match. So the way we'll do this one is I'm going to multiply this ratio, I'm going to multiply both of these numbers by 3, because that will give me a 15. And if I multiply this one by 5 and this one by 5, I will also get a 15. So when I times it by 3, I get 6 to 15. And then when I do these ones by 5, I get 15 to 20. Now that they are matching each other here and here, we can combine these two ratios together so that we can do A to B to C. A is 6, B is 15, and C is 20. So the answer for this is 6 to 15 to 20. Okay, question 11. We're going to do the fourth root of this thing that we've got here. Now you can actually split this up into two separate things when you have surds or roots like this. We can say that this is the fourth root of 81 multiplied by the fourth root of 10 to the power of 8. Now this is asking for you to think of a number that when you multiply it by itself 4 times, that we come up with the answer 81. And hopefully you can spot that that number is going to be 3. 3 multiplying by itself 4 times is 81. Now this one is where I probably would think about doing indices, that the fourth root of 10 to the power of 8, that's actually 10 to the power of 8 to the power of 1/4. If something is to the power of 1/4, it means the fourth root. And when you have indices like this, you can multiply these two things together. You can have, when you have brackets, you can multiply those powers. And 8 times by 1/4, that's 8 over 4, which is just 2. So that is just 10 to the power of 2, which is 100. So we have 3 multiplied by 100, which is just 300. So the answer to that first question is 300. The second one that we've got is 64 to the power of minus 1/2. Now there's two things we need to do here. One of the things is the fact that we have a power of a half. The other thing is that we have a power of minus 1. Minus a half can be split into these two things. Now something to the power of a half just means the square root. So I'm going to do the square root of 64, and then afterwards I will do it to the power of minus 1. Now the square root of 64 is 8. So it's 8 to the power of minus 1. And hopefully from your revision, you remember that something to the power of minus 1 means to take the reciprocal. So when I take the reciprocal of 8, I get the answer 1 over 8. So that one should just be 1 over 8. Okay, the next question is still to do with indices. All of this was to do with indices here. It wants us to write 3 to the power of n over 9 to the power of n minus 1 as a power of 3. Well, that's already a power of 3, but we're going to need to adjust this 9 that we've got here. So why don't I do that somewhere separately? Now, we know that 9 to the power of n minus 1, I can rewrite 9 as 3 squared. So it's 3 squared to the power of n minus 1. Now, this is actually sort of in brackets. With these powers here, we are going to be multiplying those together. That's the index law when you have brackets. So it's 3 to the power of 2n minus 2. When you multiply this by 2 and this by 2, you get 2n minus 2. So 3 to the power of n over 3 to the power of 2n minus 2 needs some simplifying. When you have these powers, you subtract the powers. So we're going to do that really carefully. We're going to do n subtract 2n minus 2. Well, that's going to be n subtract 2n, but here you are subtracting a negative, which becomes a plus. So we need to do n minus 2n, which is minus n, and we get plus 2. So this becomes 3 to the power of minus n plus 2, or you could write that as 3 to the power as 2 minus n. They are both the same thing. I'm probably going to go with 3 to the power of 2 minus n there. Okay, question 12. This table gives information about the weekly wages of 80 people. Complete the cumulative frequency. So cumulative frequency means keep adding on these frequencies that we've got right here. So I'm going to start with a 5 for the beginning part, and then I'm going to add on this 10. So I'm going to add this 10 on to get me 15. Now I'm going to add on 20, so I get 35. I'm going to add on another 20, so I get 55. I'm going to add on 15 to 55, which is 70. And then I'm going to add on the last 10, and we get 80, which is great because the question said that there were 80 people. It then says on the grid opposite, which I've got below, we're going to draw a cumulative frequency graph for your completed table. Now, you're going to do here, you're going to plot the top part. Unlike a frequency polygon, you're going to do the top part with these numbers that we have. So that's the 250 with a 5 and then a 300 with a 15. So 250 with a 5, 300 and what was it, 350? 300 with a 15. The 350 goes with a 35. The 400 goes with a 55. And then the last one, so 450, is going to go with, I think it said 70, and the 500 goes with 80. Yep, that's just correct. Now when you do these, sometimes they might tell you to draw them smoothly. I actually think it's easier to just draw them with a straight line, and you can just draw them with a straight line like this. You can just use a ruler. It's perfectly fine to do it like that. It does say that that's accepted in the mark scheme. So there's our cumulative frequency graph. It then says that Juan says 60% of this group of people have a weekly wage of £360 or less. So £360 or less. Well, let's think 60% of this group. Let's find out what 60% of this group is. So we're going to try and find out 60% of 80 people. Well, 10% of 80 is just going to be 8. So 60% of 80 is this being multiplied by 6. And 8 multiplied by 6 is 48. So Juan is saying that 48 people of this group have a weekly wage of £360 or less. Well, we can go to the graph and we can do a comparison. We can see how many people have a wage of £360 or less. So I'm going to go to my graph and I'm going to draw a vertical line upwards at 360. So that's 350, that's 360, 370, 380, 390. Good. So this is 360, this first one that I've got here. I'm going to draw a line up from 360 to the line, and then I'm going to draw across. So actually, it seems like Juan is not right. It seems like there are actually only 35, 36, 37, 38 people who have got that less. So I would say that he is wrong. It is not 48 people. It is about 30. And they do accept a range of different things here. They would usually accept something around that kind of point there. So it's about 38. So I need to come back and say, is Juan correct? No. There are 38 people with this wage. 38 people with a wage of £360 or less. Okay, let's have a look at question 13. It says liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 70 and a mass of 1400 kilograms. Liquid B has a density of 280 kilograms per meter cubed, and liquid B has a volume of 30 meters cubed. Work out the density of liquid C. Now you're going to need to know our MDV triangle, that we have the mass, the density, and the volume. Now it looks like they've told us a couple of things. They've told us the density and the mass of this, but they haven't told us the volume. So I think we're going to need to find the volume. And then for the second question, they've told us the density and the volume. So I think it probably makes sense to try and find out what the mass is equal to. And then we'll tackle this question that we've got here afterwards. So looking at this triangle that we've got at the top, to find out the volume for liquid A, the volume is equal to the mass divided by the density. The mass is 1,400 and the density is 70. I can cancel those zeros and I've got 140 divided by 7, which is just 20, so it's 20 meters cubed. Now for B that we've got here, we're going to try and find out the mass. The mass is the density multiplied by the volume. When you have this on the top, you multiply these two on the bottom. So I'm going to do the density times by the volume. That's 280 multiplied by 30. Well, let's do 28 multiplied by 3 quickly up here. 8 times 3 is 24, and 2 times 3 is 6. 6 plus 2 is 8. So 28 times 3 is 84. But I'm also going to add on those 2 extra zeros. So the mass is 8,400 kilograms. Now we're going to try and find out the density of liquid C. The density of liquid C is going to be the mass divided by the volume. So we're going to try and work out the mass divided by the volume. Now the mass is going to be the total mass. So that means I'm going to want to use this mass and this mass that I've got here. I'm going to want to do the 1,400 plus the 8,400. Quick bit of working out over here. That's 9,800. So that top part is going to be 9,800. Now the volume is, let's highlight these here as well. The volume is 30 for this one and 20. So the volume is going to be a 30 plus 20, which is 50. So I'm going to just simplify this fraction. I can divide the top and bottom by 10. So I just now need to work out 980 divided by 5. 5 goes into 9 once, remainder 4. 5 goes into 48, 9 times, remainder 3, and 5 goes into 30, 6 times. So my answer is 196 kilograms per meter cubed. Okay, on to question 14 here. It says Sally plays 2 games against Martin. In each game she could win, draw, or lose. In each game they play, the probability that she will win is 0.3 and that she will draw is 0.1. Work out the probability she will win exactly one of the 2 games against Martin. So there's two options, right? If she's going to win one of them when she's playing two games. She could either win the first game and then not win. She could win and not win the second game. Or she could not win the first game and then she could win the second game. So let's work out these probabilities for win and not win. Well, the probability that she wins is 0.3. The probability that she's not going to win, this is actually a bit of a red herring. We don't need what the probability is that she's going to draw. We just want to know the probability that she does not win. If the probability that she wins is 0.3, the probability that she will not win is 0.7. And then this is just going to be the same thing but the other way around. The probability that she doesn't win the first time and she does win the second time. So if you want to do this calculation, you just do 7 times 3, which is 21, and make sure you've got those two numbers after the decimal point. So both of them are 0.21. Because we want to find that probability overall, we're going to do 0.21 plus 0.21, which is 0.42. So the probability that she wins at least exactly one of the games is 0.42. Okay, question 15. We have a straight line with this equation, and the second line is perpendicular to it and passes through this point here. So if we think about the first line that we've got here, we can see that the gradient, which is the letter m, the gradient m, is 3. That's because y equals mx plus c. And pretty clearly here we can see that the gradient must be 3 by comparing those things together. Now because it is perpendicular, if we talk about L2, we know that the gradient of something which is perpendicular is that's my symbol for perpendicular, is the negative reciprocal. So I'm going to take the reciprocal, which is a third, and then I'm going to make it negative. So for L2, my equation is going to be of the form y equals mx plus c. And this is where the extra part of the question is going to come in, this 9, 5. This tells me that when x is equal to 9, y is equal to 5. And I can substitute those things into the equation. So y is equal to 5 and x is equal to 9. And I'm going to use that to find out what c is. So 5 is equal to negative a third of 9. Well, a third of 9 is just 3. So it's going to be negative 3. Then when I solve this equation, I'm going to take that negative 3, I'm going to add it to the other side so that I get 8 is equal to c. So therefore, my equation of L2, which is what the question wanted, my equation of L2 is this thing here. I'm just going to replace the c with the 8. You must make sure you have y equals at the beginning. So it's y equals minus a third x plus 8. Okay, we're doing pretty good. I think we've only got a few questions left, going up to question 18 here. Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees and she puts a mark on each bee and returns them to her hive. We don't know how many bees there are in the hive though, and actually I think that's what the question's going to be. On Tuesday, she catches 120 of the bees and she finds that 20 of these bees have been marked. So she has found that 20 out of the 120 that she caught had a mark on. And we're going to try and work out an estimate for the total number of bees in her hive. Well, we should think that the catching of those bees is going to be in the same proportion for the whole hive as it is for her sample. So for the 120, 20 of them had a mark on, and out of the whole sample, let's say that there are n in the hive, she put a mark on 90 of them. So I think we should try and simplify some of these fractions. So 90 out of the whole population and 20 out of the small sample. Well, 20 out of 12, I can cancel those zeros, and 2 out of 12 simplifies to 1 over 6. So we get 1 over 6 is 90 over n. Now you can solve this in lots and lots of different ways, but I think about multiplying the n up to this side and the 6 up to this side like this, so that we end up with n equals 90 times by 6. 9 times 6 is 54. And add on the extra 0. So we think that there's probably going to be about 540 bees in the hive. Shirley assumes that none of the marks had rubbed off between Monday and Tuesday, but maybe some of them did. If Shirley's assumption is wrong, explain what effect this would have on your answer to part A. Well, let me do this in a different colour. Let's say that some of the marks had rubbed off. We would be saying that 20 over 120, let's say that some of them rubbed off, that it became like 80. 10 of the marks had rubbed off, so there weren't 90 B's that had a mark on, there were only 80, well, we'd get a similar kind of equation. We'd have the sixth equals 80 over n. The n would go up, and we'd have 80 times by 6. So if some of the marks have rubbed off, look, we'd be getting less B's in the population. So you can always try it out with a number and see what happens. So I'm not going to include that. I'm going to put brackets around that to say I didn't really need that. But if some of the marks have rubbed off, if it went from 90 to a lower number, the number of B's in the hive will also decrease. So what effect this will have to our answer in part A? It would decrease our answer in part A. It would decrease our answer. Okay, so let's have a look at just these final two questions. Actually, no, there's a couple more. No, there's not just two questions, 18 questions left. There's quite a few. My mistake. So we're going to make f the subject of this formula. Now that means we want it to be an f equals kind of thing for this. Let's see if this is doable. Now to do this, I want to first of all recognize that I have two f's. So this is a very challenging kind of question. I'm going to begin by getting rid of this f minus 4 that's in the denominator, and I'm going to multiply it up so that I get d brackets f minus 4 equals 3 brackets 1 minus f. I'm going to expand the brackets on both sides. And then what I'm going to do is I'm going to collect everything that has got an f to that side and everything that is not an f to the other side. And then I'm going to do some factorizing. So I get df plus 3f. This minus 3f I've put and done as a plus 3f. This minus 4d is going to go to the other side and we're going to become plus 4d. Now what I'm going to do is I am going to factorize on the left-hand side, factorize the left-hand side. I'll take f out, and I get d plus 3. I have 3 plus 4d still. Great. I've gone from having two f's to just having one f by itself, so I can therefore divide by the d plus 3, telling me that f as the subject is 3 plus 4d over d plus 3. Okay, I'm going to do this question here and then I will pause my video and then I'll continue the rest of it. So here it says that x is proportional to the square root of y. That means that x is equal to some constant k multiplied by the square root of y. Sometimes people say x is proportional to the square root of y and then they write that sentence. I like to go straight to this sentence that we've got here, okay? So it then says y is increased by 44%. Well, if something increases by 44%, it starts at 100%, we add 44%, that is 144%. And I'm going to want to write that as a decimal because we don't really put percentages in equations. So if something is going to increase by 44%, it multiplies by 1.44. So that means that x is equal to k multiplied by the square root of y multiplied by 1.44. Y has been increased by 44%. Now I'm going to try and find out what has happened to x. So I think I'm going to do some of my surd knowledge here. I'm going to take this part and I'm going to split it as two square roots. And I'm going to think, what is the square root of 1.44? Well, I know that the square root of 144 is 12. So that makes me think that the square root of this might be 1.2. If I do 1.2 times 1.2, I do get 1.44. So I think I can simplify this and say that it's k 1.2 root y. Well, let's write that in a slightly different order. Let's put the 1.2 at the beginning, k root y. Well, what's happened to x? X was originally k root y, and now it's been multiplied by 1.2. If you multiply something by 1.2, that is equivalent to an increase of 20%. So the answer to this question is that the percentage increase in x is 20%. I'm just going to pause my recording here and then we'll continue with question 19. Okay, continuing where we left off, we're going to have a look at this functions question that we've got here. So it says that f and g are functions such that f of x is 12 over root x and g of x is 3 brackets 2x plus 1. Now the first thing it wants us to do is to find g of 5. That literally means just take this thing here and whenever there's an x, we're going to replace it with a 5 instead. So it's basically just a substitution question. So g of 5 is going to be equal to 3 brackets, 2 times 5, that's where we've replaced the 5 with x, plus 1. Now it's 3 multiplied by 2 times 5 is 10, plus the 1 is 11. So our answer for this first question is just 33. Now the next one's a little bit more complicated. It's a composite function. This time we want to find out what f of 9 is, and then you want to put that inside the g function. So I'm going to begin by finding f of 9. F of 9 is going to be 12 divided by the square root of 9. The square root of 9 is just 3, and 12 divided by 3 is 4. So g of f of 9 can actually be written as just g of 4. That's because f of 9 is 4, so I can replace the f of 9 with 4. And you'll notice I've just put some brackets so that it's using the correct notation. So all I need to do now is just find out what g of 4 is. Well, that's replacing the x that we have here with a 4. So it's going to be 3 brackets, 2 times 4, plus 1. Well, 2 times 4 is 8, plus the 1 is 9, so that's 3 times 9, which is 27. So we have 27 for this one here. The last one says, find the inverse function of g of 6. So it's saying put 6 inside the inverse function of g. Well, there's actually a shortcut for doing this kind of question. If you ever get asked to input something into an inverse function, that's the same thing as saying solve this thing being equal to 6. So g inverse of 6, that's going to be the same thing as if we solved the g function, which is 3 brackets 2x plus 1, being equal to 6. Because if we're putting 6 in this is the function and it output a 6. If we put the 6 back in to the inverse function and find out what x is, that's what the input was. So I'm going to solve this equation. I think the best way to solve this is to divide both sides by 3 to get rid of that 3. So that's that 2x plus 1 is equal to 2. I'm then going to subtract the 1, and then I'm going to divide by 2 so that x is equal to a half. So the solution for this is that x is equal to a half. So actually I shouldn't say what I did before. I shouldn't say x equals. It is just that the inverse 6 inside the inverse function of g, the answer is just a half. Okay, question 20. This is a Surds question, and I will try and link all my videos that I've done on these kinds of topics as well. So we want to try and simplify this, and it looks like everything is in terms of root 5 here, so I definitely think I want to see if there's any simplification that can happen to this root 180. So for the root 180, we need to try and think what two numbers multiply to give 180, where one of them is a square number. And seeing as everything is root 5 here, I think we probably should check and see what it is with the square root of 180. So I think that 180, if we divide that by 5 very quickly, 5 goes into 18 3 times, and 3 left over. 5 goes into 30 6 times. So that's actually really good. We can rewrite this 180 as the square root of 36 multiplied by the square root of 5, and the square root of 36 is 6. So it's 6 root 5. So this looks like the numerator is going to be 6 root 5 minus 2 root 5 divided by 5 root 5 minus 5. So I don't think there's any more simplification in terms of the Surd simplification, but I do think we can simplify this numerator. 6 root 5 minus 2 root 5 is just 4 root 5. So we get 4 root 5 over 5 root 5 minus 5. Now the next thing that we need to do is get this denominator, we need to rationalize the denominator. So to rationalize the denominator, I hope you've learned this before, you take the same thing that's on the bottom, but you switch it, you find the conjugate, which means you change it from a negative there to a positive, and obviously everything else just stays the same. And you multiply it by that on the top as well, so that's 5 root 5 plus 5. So for the numerator, we're going to have the 4 root 5 times the 5 root 5. Now you might like to do some calculations somewhere else. 4 root 5 times 5 root 5. Well, the 4 times the 5 gives the 20. The root 5 times the root 5 gives a 5. And just 20 times 5 is 100. So that first two things being multiplied is 100. Then when I multiply these two things, I get 4 root 5 times 5, which is 20 root 5. Now onto the denominator. You get the 5 root 5 times 5 root 5. Well, again, doing some working out down here, that's 5 root 5 times 5 root 5. 5 times 5 is going to give you the 25, and we have a root 5 times a root 5, which is another 5, and 25 times 5 is 125. Now you could do all of the double brackets here, but what you're going to get is some of them cancelling out. You're going to get this one with this one, and this one with this one cancelling, because you're going to get the positive and negative version of exactly the same thing. So I'm just going to do the last part, which is these two, which is the negative 5 times 5, which is minus 25. So what we need to do now is just simplify the denominator. So that's 100 plus 20 root 5, all divided by 100. And then we can just split the numerator so that we have two separate fractions. So we have a 100 over a 100 plus a 20 root 5 over 100, and all that's left to do is to simplify these two things. So 100 over 100 is just 1, and 20 over 100, because I can ignore this root 5 for a second, 20 over 100 is just going to simplify to 1 over 5. So that means that I can say this is plus root 5, 1 root 5 over 5. There's like a 1 there, but I'm just not going to write that down. So it says where a and b are integers. Clearly a is the first one, so a is equal to 1. You don't have to do this bit. And b is equal to 5, but I always like saying what the a and b are that it might be looking for. Okay, so nearly there. We've got a few questions left. Let's have a look at question 21, which is a vector question, and it's a proof question for this. It says that P is the midpoint of FD and Q is the midpoint of DE. So that side and that side are equivalent in length, so I can just do a quick little dash to say they're equivalent, and also these are equivalent. That might not be necessary though. It says that FD is equal to A. So I might not need these as long as we remember that it's the midpoint. So the whole vector from here to here is A. But I think that's going to make my diagram get a bit busy, because I'm actually going to say, because this is the midpoint, I'm going to say that this section is the half A, and then this section here is also the half A that we've got. And then from F to E, it is B. So this bit running along the bottom here is B. And it says use a vector method to prove that PQ is parallel to FE. So I'm going to add in a line for PQ, and we're going to try and prove that this PQ is parallel to FE using only vectors. Now it's pretty obvious that they are parallel, but we're going to try and prove it. So the way that you can prove that vectors are parallel is if they are multiples of each other. So I'm going to begin by finding out the vector PQ. Well, actually, I'm going to write down what FE is. FE, very obviously, is equal to B. So if we can find out that PQ is something just as a multiple of B, then we're sorted. So to get from P to Q, looks like there's many different ways you could go. I would probably travel up here and then here. So I'm going to go from P to D, and then I'm going to go from D to Q. Well, I know what P to D is. P to D is just a half A. And D to Q is a half, because it's the midpoint here, a half of DE. It's a half of the journey from D to E. Well, I don't have this journey from D to E, so I need to work out what that journey from D to E is. Well, to go from D to E, I'm coming backwards along this line here, and to go backwards along a vector is the same vector but negative. So the whole vector in this direction was A, so in this direction it's going to be negative A, so it's going to be negative A. And then I'm going from D to E, aren't I? So I'm going to go backwards along here, and I'm going to add on this FE, which is B. So I get minus A plus B. Remember, I was finding out what this is so that I could substitute it in this, and I could complete what PQ is equal to. So PQ is therefore a half A plus a half of what we just worked out as DE, which is minus A plus B. Now all I'm going to do is expand the brackets, so that's a half A, minus a half A, excuse me, for this next part, plus a half B. Now this half A and this half A cancels, so we just get left with a half B. So we just need to now finish off, because it's a proof question, to just kind of write a sentence. Because this one and this one are multiples of each other, they are therefore parallel. So I'm going to say as PQ, and actually PQ is equal to a half of FE, they are parallel. And in fact, we know even more than that. Not only are they parallel, but we know that the length of PQ is half the length of FE. So this line I've drawn here is half this one that we have. Okay? Now I'm going to have a look at question 22. This one says we have two shaded shapes, A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of a circle with a radius 5x minus 1. So they've actually told us that this whole radius is 5x minus 1. Kind of obvious though, because 2x plus 3x minus 1 is 5x minus 1. Shape B is a circle with diameter 2 minus 2x. And they're telling us that the area of this shape, this shaded part, only the grey part, is equal to this area as well. find the value of x. So I'm going to just quickly deal with, I think, probably the easiest shape to begin with. They've told us that the diameter of B is 2 minus 2x, and we know that the radius is half of that, which is going to be 1 minus 1x, or actually just 1 minus x. So if I'm going to have a look at the area of shape B, we know that the area of shape B is pi r squared, which is going to be pi 1 minus x all squared. I'm just going to leave it like that for now. Now I'm going to have a look at the area of shape A. It looks like it's going to be the sort of slice area minus the small little slice that we've got. That's what's going to give us this kind of shape that we have here for A. That's going to be the shaded thing that we want. So we're going to do the big sector subtract the small sector. Now when you find the sector, this is 45 degrees. Now if you think about 45 degrees out of 360 degrees, hopefully you recognize that 45 degrees out of 360 degrees is a nice fraction. You can actually say that this is equal to 1/8. So this is 1/8 of the whole circle, meaning when you find the area, you're going to divide it by 8. So I'm going to begin for this first part. The radius, they told us, is 5x minus 1. Remember they said that that was those two bits added together, the 5x minus 1. And then the smaller radius is 3x minus 1. So I'm going to put both of those things into this. I'm going to do pi r squared, so that's pi 5x minus 1 squared, but it's going to be divided by an eighth, or sorry, it's going to be divided by 8 or multiplied by an eighth. And I'm going to subtract the same thing, so it's going to be an eighth of pi 3x minus 1 squared. So this is what the area of A is equal to. I'm just going to shift that across so I've got a bit more space. Now it says that these are equal to each other. So this means that pi 1 minus x squared is equal to an eighth pi 5x minus 1 squared minus an eighth pi 3x minus 1 squared. Okay, well there's some definite things we can do to tidy this up quickly. I can divide everything by pi. I can divide this, this, and this by pi. And I'm also going to make this a bit easier by multiplying everything by 8 to get rid of those fractions. So when I multiply this by 8, I'm going to have 8 multiplied by 1 minus x squared. The 8th is going to disappear, so I'm just going to have 5x minus 1 squared. And then I'm going to have minus 3x minus 1 squared for that part that we have. Okay? So we just need to do a lot of expanding and factorizing and see what's going to happen in this case. So I'm going to do 8. We're going to do 1 minus x squared. That's going to be 1 minus 2x plus x squared. That's our double brackets that we've got there. Here, when you square this, you're going to have the 5x times 5x, which is 25x squared. You're going to get a minus 5x and a minus 5x, which is minus 10x, and you get a plus 1. And then here you're going to get a 3x times a 3x, which is a 9x squared. You get a minus 3x and a minus 3x, which is a minus 6x, and then you get a minus 1 times a minus 1, which is a plus 1. So expanding these brackets, you get 8 minus 16x plus 8x squared. These brackets don't do anything at all, so I can just leave them like this. But these ones, you're going to negate everything. So this is a minus 9x squared, but the next one, because there's a negative and a negative, it becomes a plus, and that becomes a minus. So I need to do a little bit of tidying up. Okay, let's see if I can put everything all on this one side. So I've got 25x squared minus 9x squared. Well, 25 take away 9, that's 16. But I'm also going to have to take away the 8 as well. So I'm going to get 8x squared for the x squared terms. I've then got a minus 10x plus 6x, that's minus 4x. But I'm going to add 16. So I'm going to be doing minus 4, add 16, that's going to give me 12x squared. 12x, sorry. Then all I need to do is with the constant terms that we've got here. So I have a 1, take away 1, well they cancel, and I just need to subtract this 8 as well, so I get subtract 8. And that is equal to 0. So now that I've got it at this stage where it should be equaling to 0, I need to just finish by solving this equation. Looks like I can divide everything here by 4. Looks like it's all in the 4 times table. So that's going to give me a 2x squared, a 3x, and a minus 2. That was me dividing by 4. Now, they don't really give enough space for this, so I might need to shift some of this just to give me a little bit more space. Let's just put that there for now. Now I just need to go about solving this. So you can think about how you might factorize this. I think when I go about factorizing this, it's actually quite an easy one. You don't need to do any long method for this because we know that the start part has got to be a 2x and an x. And then the only numbers that can go in here are a 1 and a 2. That's the only way we can get this. So I think in order to do this, I'm going to put a plus 2 over here. That would give me a 4x. And then I'm going to put the minus 1 over here. That gives me minus x, and 4x minus x is 3x. So this is going to give me two solutions. Either this one is that x is equal to minus 2, or this one here, we want 2x minus 1 to be equal to 0. That means that it's 2x is equal to 1. It means that x is equal to a half. So only one of these is going to make sense. This one here does not make sense because it is a length. You can't have a negative length. So we will reject this answer, and we will say that the answer is that x is equal to a half for this question. So the value of x is a half. Very, very difficult question, but it is a 5-mark question. Okay, we are on the last question of the exam paper. It says there are 4 types of card in a game. Each card has a black circle or a white circle, or a black triangle or a white triangle. And the number of cards with a black shape to the ratio of the number of cards with a white shape is 3 to 5. The number of cards with a circle to the ratio of the number of cards with a circle to the number of cards with a triangle is 2/7. And it says express, this is the important part, the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So we are going to do the black shapes over the triangle shapes. And the trick for this question is that ratio is basically not that fun to deal with. You kind of want to change ratio questions most of the time into like a fraction kind of question, particularly for these challenging kinds of ones. So if we begin by thinking about what fraction are black shapes, well, there's 3 to 5. So that must mean that the black shapes are 3 out of 8 because there's 8 parts in total and 3 of them are black. And then for the triangle shapes, we're going to do the same thing but with the second ratio. It is going to be number of them with a triangle is 7 and the total parts is 9. So we want to do a fraction of the black shapes over the triangle shapes. Now we're going to just use this straight away. We're going to say that the black shapes are 3/8 and that is as a fraction out of 7/9. Now this is not how they want the answer presented. You're not likely to want to write a fraction as a fraction with a fraction of 2 fractions like this. So what we're going to do is just change it. We're going to say that it's a 3/8. This line here means it's being divided by, so it's 3/8 divided by 7/9. We know how to do this now. We're just going to keep this one like this. We're going to flip this one over so that it's 9/7. We're going to take its reciprocal, and we're no longer going to do a division. We'll do a multiplication. So 3 times 9 is 27, and 8 times 7 is 56. So 27/56 is the fraction of cards with a black shape out of those with a triangle on, 27/56. So that's the whole paper. I think there were some pretty challenging questions in here. I will try and link some of these where I've done like similar kinds of things for full teaching. Like I said at the beginning, this is not going to be me teaching you how to do this. This is just me kind of showing you the answers to these questions so that you can practice them and hopefully get better with them. Okay, good luck with your studies.